Alright, here's a really nice problem without too many words. You're just looking at the table, answering the questions. So, given that a randomly selected voter is male, what is the probability that he is registered to party Y or for party Y? So, we just want to phrase this, the probability. Oh, so given that he's male, so that would be given male at the end, we want to know the probability of party Y. Fantastic. We can do this all kinds of ways. You can probably do this straight from the table, or you can use your combined conditional probability method. So the probability of Y and male divided by just the probability of male. And we look at this and we say, all right, probability of Y and male, well, that's 48 people out of a total of 500. So 48 500ths. All divided by the probability of male in general. I'm going to erase these guys so it's not confusing, which is going to be 200 500ths. So 200 out of 500. Of course, those denominators cancel. We get 48 200ths, which you could reduce, or you could just write as 0.24, which I think is a nice way to do it. Awesome. If you wanted to look at this right away and see, 48 out of 200, I can just see that immediately, because there's 48 people who are male in this world, who are supporting party Y in this world that they are male. There's my 48 out of 200. You can skip right to that. That's totally fine. But I just wanted to show you that the conditional probability formula still holds if you choose to use that. Now, among the registered voters, are the events is a male and is registered for party Y independent? Chances are it's about humans. Most of the time the answer is no, but we need to check that, and there's a lot of ways to do it. But in my mind, I'm thinking, okay, well, if they are independent, and since I just figured out that the probability of Y given male is equal to 0.24, let me figure out what the unconditional probability of someone supporting party Y is. And so that's just going to be party Y in general. We're going to look over here. There are 168 total people who support party Y of all the genders listed, which is 2. And then we've got this total number of people of 500. And so we get 168 out of 500, which is 0.336. I believe. If that's slightly wrong, it's not going to be a big deal. And we can notice that the probability of Y does not equal the probability of Y given M. So they are dependent. They are not independent. What this means is that if you know someone is male, it tells you that they are less likely to support party Y. We have that given. There are, of course, other ways to do this. You could also show that the probability of Y and male does not equal the probability of Y multiplied by the probability of male, because if they are independent, it has to actually be that they are equal. And we're going to be able to see quite easily that these two things are not equal. And we can see probability of Y and M. It's going to be 48 out of 500. And we'll notice very quickly that this is not going to be equal to the probability of Y, 168 over 500, multiplied by the probability of male, 200 over 500. You can grab a calculator and check that these two things are not equivalent, but I assure you they are not. And so for those reasons, we can say that, again, it's not independent, it is dependent. Fantastic. Now, what we see in problem C is that they say, okay, well, let's imagine that they are independent. Let's take this world where it says down here in Lawrence Township, which we don't know, we say the party registration is independent of gender. So what that means is down here, I'll do this all in pink to make it really obvious, match it up with the highlighter, is that the probability, this is in part C, the probability of supporting party W is equal to the probability of supporting party W given that you're male equals the probability of supporting party W given that the person is female. These all need to be the same thing. And what it's telling you is that the total unconditional probabilities of party membership are the same as in Franklin Township. So what we just need to do really quickly, and I'll zoom out and do it over here, is find the probability of W, which is just equal to 88 out of 500, which is roughly 0.176. Don't know why I did that roughly. It's actually exactly that. And the probability of X is 244 out of 500, which is equal to 0.488. And probability of Y is equal to 168 out of 500, which is equal to 0.336, which we saw before. That was that same one over there. And so we can look at these three things, and it's telling us it's independent of gender. And so the situation here is that they want you to have party W, party X, and party Y the same for both female and male. That's what it means. It does, if you switch the gender that you're thinking about or considering, the party affiliation probabilities do not change. That's what independent means. Not that they're mutually exclusive. That would be something different. But that the probabilities do not affect one another. So the occurrence of one does not affect the likelihood of the other. Just trying to say the same thing in a million words, so you just want to do your best. We're looking at 0.176 for party W, and it's got to be the same. So this is going to be W and W. And then 0.488, so we're trying to add that to this. We're trying to have this middle 50% roughly, this middle 48.8%. And you just want to estimate that the best you can. And it's going to be somewhere around right there. And we just want to do the same thing for both X and X. And then the remaining should be a little bit more than 0.3. And you can see that it's a little bit lower than 0.7 all the way up to 1. That's a little bit more than 0.3. And we're good. There's your Y's. Those are matching up with these three numbers. But it's showing you the width of these. Because if we look sort of, for example, up here, we notice that it goes from 0.15 to 0.75, so that would be a space of 0.6, something like that. And that's showing party X out of the 200 for men in Franklin Township. So you get that sort of 120 out of 200. It's about 0.6, a little bit more. But that's the idea there. Hopefully we're all good, and this one didn't seem too crazy.